Hello everyone. In this video, we'll be discussing a very interesting system design problem. So suppose you have a social media app and you want to design a special feature where you can show your users what were the top key hashtags that were used in the last 24 hours. So in this, we'll be seeing a in-memory solution, but in the later video, we'll be seeing like solution for the like bigger systems. So suppose you have like n unique hashtags. So we will start off by creating n separate queues for them so that each of the hashtags has their own queue. And this queue will be like storing the timestamp of when that hashtag was used. So suppose like in any time a hashtag was used, we'll be adding that particular timestamp at the end of that queue for that hashtag. And also we'll have a process or a cron which will be like seeing at the top of this queues and see if like any of the hashtag or the timestamp is like older than 24 hours. Then we'll just like keep on popping from the queue until we reach a timestamp which is under 24 hours from the current time. So this is basically to ensure that we're just storing only the hashtags or the timestamps that were used in the like last 24 hours. And now we'll like add in another data structure in our design, which is a priority queue. It's gonna have the hashtag and its count. The count will get from these queues that we have created, and also a Y priority queue or a max heap, so that like at the top of this priority queue will always have the hashtag with the like most number of counts or like most number of usages in the last 24 hours. And how this priority queue will get updated, it will get updated by the trigger events that will be triggered by these queues. So whenever the item is added or popped from the queue, it will send the trigger event and will update the count for that particular hashtag in this priority queue. Now coming to the last part, that how we can like get the top k hashtag. So we'll just keep on popping from this priority queue for k number of times and we'll just get the top k hashtags that were used in the last 24 hours. And the time complexity will be like k log n, where n is the like total number of hashtags that were like there. So yeah, this is the like solution, and you could like change the data structure from priority queue, the sorted set, to the sorted set, and you could like optimize in this update operation that we are doing, but it's like totally up to you. So this is the like high level idea that how we can achieve this. Now we'll see a little bit of storage estimation. So suppose we have like 2 billion of hashtags, and like since we are storing a timestamp and it is a 32-bit timestamp, so total storage size would be like 8 GB for like storing this all hashtags in this queue. And also we are storing those all hashtags in this priority queue as well, so 8 GB more. So it will be like now 16 GB of total storage. So 16 GB is like pretty normal for today's modern like hardware, and we could like definitely have like 16 GB of RAM in our machine and could store all of this data. But yeah, now let's move on to the limitations. So now let's say we have like some ask comes, and now we want to like develop it for like last 30 days. So since just for like last 24 hours it was taking 16 GB, so for next, like if you want to like have for like last 30 days, it's gonna take like a lot more space than like 16 GB, and we just like cannot put that in the RAM. So yeah, that's like a big limitation, like hardware limitation. And also if like system crashes or like reboots, all of our data is just gonna like go away, and we're just like gonna lose them all. And also like if there are like multiple instances of our server, then the data could vary between like one instance to other, and the user could see that like different results because each of these servers have their like own RAM. And if the request is being like propagated to like different instances, then they could like return different results. So yeah, that's like not ideal. So yeah, or basically not consistent. So yeah, we'll just see like how we can like build it for like bigger systems. So yeah, thanks a lot.